So this is going to be the answer key for the 6163 review. Feel free to fast forward any place that you need to. I'm not sure how long this will actually take, but it's probably going to be about 15 minutes is my guess. You definitely want to have your calculator with you so you can figure out what to do with that as well. So if you're trying to figure out if a triangle that's got these three lengths is a right triangle, you need to see if it fits into the Pythagorean theorem. So if a squared plus b squared equals c squared, you know you're good. But the question is which is the longest leg? And everybody seems to think that 9 is, but that's not the case. So if you were to go onto your calculator and you take a look at these lengths, if I were to see what 3 times the square root of 3 is, that value is 5.1. 5.2 doesn't make a difference. It's 5.1 and change. If I take a look at 6 radical 3 and get that decimal equivalent, that length is 10.39 and change. So 6 rad 3 is the biggest side. So then what I'd have to do is say, does 3 square root 3 squared plus 9 squared, does it in fact equal 6 square root 3 squared? Well, 9 squared we know is 81. When I do 3 rad 3 squared, I do 3 times 3, which is 9. Radical 3 squared is just going to be 3, so this gives me 27. So then 27 plus 81, what's that going to equal? Well, 6 rad 3 squared becomes 36 times 3, which is 108. Well, does 27 plus 81 equal 108? And it sure does. So this would definitely be a right triangle. Number 2, which set of numbers represent the lengths of the sides of the right triangle? Well, either know something about Pythagorean triples or test each one in your calculator. Well, I know that 6, 8, 10 is a right triangle. I can stop right there. But if I didn't, I'd be in my calculator and I'd be doing 4 squared plus 5 squared, does it equal 9 squared? And 8 squared plus 9 squared, does it equal 10 squared? So you got to do all that. The next one asks about finding the value of x squared. So use the Pythagorean theorem to solve for x squared, not for x squared you have to read. So basically what you need to do is you need to square the legs and see what x squared becomes. Well, when I do this, x squared plus, well, radical 17 squared is just 17. 15 squared with calculator, just because you know it, is 225. When you subtract 17 from both sides, you get x squared equals 208. You're done. It asked for x squared. You have x squared. So the answer then becomes 208. Okay, let's see. The area of a square is 200 square centimeters. How long is the diagonal? The area of a square. The area of a square is base times height. If I have a square, all my sides are the same. All my angles are right. I need to figure out what the length of a side is. Well, if the sides of a square are the same, then I've got base times height, or x squared, equals 200. That then means that x, or the length of a side, is 10 radical 2. So now I go back into my square and I say, well, if this is 10 rad 2, so is this. This now becomes a 45, 45, 90, in which the legs take x and the hypotenuse takes x rad 2. Well, if I want to plug in what x is into the hypotenuse, then what I'm doing is 10 rad 2 times rad 2 equals 10 times 2, or just 20. Choice 1. In triangle ABC, angle A is a right angle, B is 60. If AB is 20, find BC. If necessary, round your answer. Okay, so we've got Triangle ABC, we know A is a right angle. It doesn't matter where B goes. I'm going to put B here. B is 60. This must be C. This must be 30 degrees. They want you to find BC, the hypotenuse, which means the leg opposite 30 degrees is X, opposite 60 is X rad 3, hypotenuse is 2X. This is what we're looking for. What do we know? AB is 20. So if X is 20, then twice X must be 40, which means BC must be 40. Alrighty. 6, refer to the triangle shown below. We've got a 45, 45, 90 for 6A and B. And how do you know that? Because these angles are marked congruent. So that means I've got an X, and an X radical 2. I don't care about their little letters here, but I guess we need that for the answer. So let me get rid of that for a second. Okay. So if X is 12, so if a leg is 12, then the other leg is 12, and the hypotenuse is 12 rad 2. So this becomes 12, this becomes 12 rad 2. Now they tell you Y is 1.5. So if Y is 1.5, that's a leg, X is 1.5, and Z is 1.5 rad 2. That's it. On 7, we've got 30, 60, 90. So this little leg X, or this little leg A is X. This little leg B, X rad 3. And then C is double X. If A is 10, well, if A is 10, then B is 10 rad 3. And C is 20. That's pretty easy. Let's see. If B is 8 rad 3. If you're given the rad 3 side that has the rad 3 in it, then life is grand because A is just 8 and C is just 16. Okay. Next one. Find the length of a side of a square whose diagonal is 4 centimeters. It's a square. You know that squares have all sides the same, which means you're in a 45, 45, 90. If the diagonal is 4, you need to remember that that's the x radical 2 side. If the x radical 2 side equals 4, then the leg is the shortcut. Divide by 2, multiply by rad 2. The side is going to be 2 rad 2. Number 9, shout out to Katie Adler because we're talking about turn angle Mieses. Not really sure, a little bit of a typo there, 2 typos, and Katie found that for us. So on 9, if one side of an equilateral triangle, not a turn angle, measures 6 centimeters, find the measure of the altitude. This is how we actually derived 30, 60, 90s. If you are equilateral, everything is going to be 60, 60, 60 for your angles. That's your angles. But if you're equilateral, all your sides are the same. The altitude is just the height. If you drop down the height, you now have a 30, 60, 90. And what ends up happening then is this is your 60, this is your 30, right? And we knew that this was already 6 because it was part of the equilateral. And this becomes x, x rad 3, twice x. Well, if 6 is 2x, then x equals 3, and then your altitude becomes 3 rad 3. So the altitude is 3 rad 3. Number 10. The hypotenuse of a 30, 60, 90 is 3. Find the perimeter. Well, they're giving you a lot of fractions here, so let's see what we can do with that. So we've got this triangle, 30, 60, 90. The hypotenuse is 3. I'm just going to call this guy 30. We'll call this guy 60. So we know that we've got x, x rad 3, twice x. Well, if the hypotenuse is 3, then the short leg has to be 1.5. And then if the altitude, or this x rad 3 side, becomes 1.5 rad 3. Well, I need to add up those pieces. I've got to add 1.5 plus 3 plus 1.5 rad 3. 4.5 plus 1.5 rad 3. Well, they don't give me decimals, but I know 4.5 is just 9 halves, and I know 1.5 is just 3 halves. 9 halves plus 3 halves root 3, and this becomes choice 2. Number 11. All these guys. So find the values of x and y. So again, I'm not worried about so much of x and y. I'm just going to put all the way around the triangle that this should be my x rad 3 side. This is my x side, and this is my twice x. Well, the fact that 12 is x rad 3, my short leg says take 12, divide it by 3, multiply by a rad 3, which means this side right here is 4 rad 3. This guy right here becomes 8 rad 3. 12, x, x, x rad 2. This guy becomes 6 rad 2. This guy becomes 6 rad 4, or 6 times 2, which is just 12. Thirteen. 30, 60, 90. X, x rad 3, and 2x, which means that the longer leg becomes 4 rad 3, and the hypotenuse just becomes 8. This one's got a couple things going on. If I look at just the 45, 45, 90 right now, if I just look at this, where this becomes x and this becomes x, this is my x rad 2 side. So when I go backwards, I take 8, I divide by 2, multiply by a rad 2, which means this becomes 4 radical 2. This becomes 4 radical 2. But now in my 30, 60, 90, this is still the x value, so that's good. So this is my 4 rad 2 for x. This guy right here becomes x rad 3, and this becomes twice x, which means if I'm 4 rad 2 for x, I'm 4 rad 6 for the longer leg, and then I'm 8 rad 2 for the hypotenuse. Okay, last page. 15. In the figure below, what's the length of PQ? Well, PQ happens to be the 2x side of a 30, 60, 90 triangle. So this happens to be a 2x side, where this guy right here happens to be PS, I should say, happens to be the x radical 3 side. And then this guy right here happens to be the x. They want PQ, so they want us to get to the hypotenuse. So what ends up happening is if 9 is the x rad 3 side, then take 9 divided by 3, multiply by a rad 3, which means this guy right here, the x becomes 3 rad 3. To get PQ, multiply 3 rad 3 by 2, and that just becomes 6 rad 3. In the figure below with the altitude of 6, find the measures of x, y, and z. So we're dealing with a 45, 45, 90 and a 30, 60, 90. In the 30, 60, 90, this becomes 30. This becomes the short leg. The longer leg is down here, which is x rad 3 or 6 rad 3. There's that value. And the hypotenuse just becomes double 6. So this guy right here is 12. On the other side, we're in a 45, 45, 90, where these are also the lengths of x, which means this guy becomes x rad 2 or 6 rad 2. Last but not least, 17. Diagonals of a rectangle intersect and form vertical angles of 60 degrees each, and 120 degrees as well. If the length of the diagonal is 12, find the dimensions of the rectangle, the perimeter of the rectangle, and the area of the rectangle. Alrighty, let's see what we got. Rectangle. We know these are 90. These diagonals intersect and they make 60 and 120. So we're going to make this guy 60. We're going to make this guy here 120. We're going to make this guy 60. This guy here 120. What ends up happening then? So the diagonals of the rectangle bisect each other. I'm not so sure that you know that. I don't know if this will be on the test tomorrow, but as it turns out, if I were to just kind of focus on this bottom triangle down here, since the diagonals of a rectangle, bisect each other, it ends up being that we've got these guys being congruent, which forces these angles here in the corner to be 30 and 30. And then what happens is when I move into this bigger, oops, I didn't mean to do that. When I move into this bigger triangle, and I'll erase all this stuff in a second, this triangle right here ends up being that I've got this bottom angle down here being 30, my right angle being my right angle, and this top angle here being 60. So from my rectangle, I get into a 30, 60, 90 right triangle. So what I'm going to do, I guess, is label some stuff. What do we know? The length of the diagonals happen to be 12. So this guy right here we know for sure is 12. In a 30, 60, 90, the short leg takes x. This guy takes x rad 3. This guy takes 2x. So what that means is the short leg ends up being 6, and then the longer leg equals 6 rad 3. Well, the fact that we're in a rectangle, can I get rid of this thing? Delete it, right? Oh, nope, that's not what I wanted to do. Let me cut that out. And I want to delete that. There we go. Oh my goodness, this is not working for me. Hold on. Bear with me for 1 second. Oh, okay, this is just comical. Very comical. Now it's all screwed up. Okay, well here we go anyway. So, sorry, this is rather funny, but if I take a look at the rectangle, my dimensions then would be 6 rad 3 by 6. So that would be A. So A becomes 6 rad 3 and 6. B asks for the perimeter of the rectangle, which means I'm going to have 2 6 rad 3s, or 12 rad 3, plus 2 6s, which means plus 12, because remember, I've got to add up all my like terms. And then the area of the rectangle, this ends up rather comical, the area of the rectangle is base times height, which is 36 rad 3. And there is the answer for this messed up page. Okay, so that's it. Hopefully this is going to be helpful to you for tomorrow. Again, concentrate on the fact that if you don't know if something's a 30, 60, 90, then you have to just use Pythagorean theorem. And then if you know it's 30, 60, 90 or 45, 45, 90, then you use those shortcuts that you know. All right, so good luck with the quest on tomorrow. Bye.